This video is the second in a series of videos intended to give you the basics that you need in order to get started using Git. In this video, you're going to learn how to branch code and why that is useful. You're also going to learn how to use the GitHub online repository as a way to facilitate group coding projects and open source coding projects. To help teach you about branches and how to navigate them, I'm going to be using this visualization tool created by github.com. I've given you the web address, and I do recommend that you go and play with this on your own. It's a very good way to clarify concepts in your mind. You can click the drop-down menu and play around with different simulations. To use the simulation, you type your command here and hit enter. The command appears here, and the simulation will create a visual representation of what your command just did. So here, I just made a commit, and if I make another one, you see it appear on screen. So you can see that your repository is essentially a chain of commits connected one to the next. Now you can also create another branch, move on to it, and start making a chain of commits anchored to it instead. So let's do that next, but remember there's two stages to it. I have to create a new branch, and then I have to move on to that branch. To create a new branch, I type git branch and then the name of the new branch. It appears down here, but because I haven't made any commits to it yet, it doesn't look very interesting. Now I want to take the opportunity here to explain what some of these labels you're seeing mean. Master is the name of the original branch that you're on, so that's the default name of the first branch. You can also see that we've created the branch called Planet. So what's this thing called the head? Well, you can think of the head as being the thing that writes the next commit. So wherever the head is pointing to, that's where your next commit is going to be anchored from. Now it may not be clear from the visualization, but right now the head is still pointed to the master branch. So I've created the new branch, but I haven't actually moved on to it yet. That means if I make another commit right now, it'll still be on the master branch, not the planet branch. So let's look into how to switch branches now. The command to switch on to another branch is git checkout and then the branch name. So you can see that that's what I've typed up here, and down here you can see that the head has moved back to the planet branch. So now if I do a commit, you now see that we're on the planet branch, which is to say that we're making a new chain of commits called planet. So I'll make another commit here on the planet branch, and then we'll create some new branches and commit onto those as well. So to create a new branch, I type git branch Saturn, and then remember that I have to switch onto that branch if I want to make any commits to it. And I do that by typing git checkout Saturn. So that puts me on the Saturn branch, and now I can make commits to it. So now let's go back to the planet branch, and remember to change branches you use the checkout command. So git checkout planet. And as you can see, that has moved the head back to the planet branch. So now let's create another branch off of this. So we type git branch Jupiter. That creates the new branch, and now we want to switch on to it. To switch on to it, we type git checkout Jupiter. That puts us on the new branch, and we can now make commits to it. So let's do that one last time for clarity. To move the head back to the planet branch, we type git checkout planet. To create a new branch, we type git branch Venus. To move the head onto that branch, we type git checkout Venus. And then we can make commits onto the Venus branch with git commit. So this all helps you understand branches and how to navigate them, but the next question would be, how does it help? What is this good for in coding? Well, that's what I'll explain to you next. First, let's start fresh. So here's a new project with a few commits on it. And let's say that this is code that was provided to you by a colleague or an instructor. And your job is to add 3 functions to this. But let's say it's not just you, you're actually working as a team of 3 people. So there's 3 functions that have to be added, 3 people in the team. You decide to split up the work and have each person work on one function and get it working individually. This is where branches can help you because you can make 3 branches of the code, and then each person in the group can be working on their own branch of the code simultaneously. So you don't have to be passing the latest version of the code back and forth. Every person in the team has their own branch of code to work on. You're going to be able to merge all your branches of the code later. So let's make the 3 branches now. I type git branch function 1 to create my first branch, git branch function 2 to create the second, git branch function 3 for the third. And now I'm ready for various members of the team to check out a branch of code and start working on it. So the first team member checks out their branch of the code by typing git checkout function 1, and then they start working and making their commits. And in the meanwhile, another member of the team can start working on their code too. To check out their code, they type git checkout function 2, and then they can start making their commits too. And now you begin to see why the command to change branches is called checkout. Just as when you go to the library, you check out a book so you can read it, all of your team members are able to check out a branch of the code so they can work on it. So again, to check out a branch of the code, you would type git checkout function 3, and then you would begin making your changes and committing your code to the repository. And assuming that you're all uploading your code to an online repository, you can also check out somebody else's code once they've uploaded it and make further changes to it. So to demonstrate that, git checkout function 2 to move on to the function 2 branch, and then you can make more changes to the code and commit them. Now at this point, you've got 3 versions of the code with 3 separate functions, and you want to merge them all back into the master branch. To do that, you first need to get back onto the master branch. So git checkout master gets you back on that branch, and then the command to merge is git merge and the branch name. So git merge function 2 in this case. Now it's not clear from the visualization what happened here. It'll be more clear when I do the next 2 merges, but the program just created a new commit that has 2 parents, the master branch and the function 2 branch. So let me do another merge now. I type git merge function 1, and now you can see that there's a new commit that has 2 parents, the master branch and function 1 in the middle. And if I type git merge function 3, again, it makes a new commit with 2 parents. And you'll notice by the labeling that I'm back on the master branch now exclusively. So this demonstrates the usefulness of branches in that you can use them as a safe development area to work on new features for your code. And when you're certain that they're working correctly, then you can safely merge them back into the original code. Even if you're not working as part of a team, just on your own, this is a good practice. Now, after you've finished using your branches as a development area and everything's merged back into the master branch correctly, then you might want to delete your branches. You're not deleting anything in your commit history, you're just deleting the labels on the branches. So let me show you how to do that. You can either type git branch -d and then the branch name, so I just deleted function 1's branch, or you can type git branch -- delete and then the branch name, which I've done to delete the function 2 branch now. And again, git branch -- delete function 3 deletes the function 3 branch, and so now only the master branch is left. So let's see what that looks like on the command line. So I've used the change directory command to get into my lab1 folder, and I'm going to type git branch with nothing after it in order to check what branches exist in my project right now. And it only lists the master branch with a little asterisk beside it. If I have more than one branch in the project, the asterisk would be beside the branch that I'm currently on. So I'll create a new branch with git branch new function, hit enter, and it doesn't look very interesting, so I'll type git branch again, hit enter, and now it lists 2 branches, new function and master. But the asterisk is still beside the master branch because I have to use the checkout command to move on to the new function branch. So I'll do that. I'll type git checkout new function, hit enter, and it tells me it has switched to the new function branch. So I'll type git branch again, and now the asterisk is beside the new function branch to show me that I'm now on that branch. So next, I'm going to show you how to use the GitHub online repository. When you're working with Git on your local computer, you've got a local working area, a local staging area, and a local repository. With a website like GitHub, you've also got an online repository, and you can push your commit history from your local repository up to the online repository, or you can pull the online repository down to your local repository. This is good if you're working in a group because everybody in the group can push or pull information to and from the online repository, and that provides a very convenient way for you all to stay up to date on each other's work. Now, the convention is to call the online repository origin. You could call it anything you wanted. You could call it the Lab1 online repository, for example, but I'm going to use the convention also, so I'm going to refer to the online repository as origin. That's the name we're going to give it. It's also referred to as the remote. So I'm going to quickly set up the branch structure that we had earlier in order to show you how to push branches to the online repository. So git branch planet to create the planet branch, git checkout planet to move on to that branch, make 2 commits, git branch Saturn to make a new branch, git checkout Saturn to get onto it, make 2 more commits, git checkout planet to go back to that commit, then git branch Jupiter, git checkout Jupiter, 2 more commits, then git checkout planet again, git branch Venus, git checkout Venus, and 2 more commits. So now I'm ready to push branches up to the online repository. But before you push a branch, you want to be on that branch. So I'm going to do the Jupyter branch first. Git checkout Jupyter puts me on that branch. Git push origin Jupyter pushes to the origin online repository the local branch that's called Jupyter. Now notice that the entire Jupyter branch went to the online server, including its entire commit history. However, the Planet branch did not go to the online server, even though the Planet branch is part of Jupyter's history. If you don't push a branch, it doesn't go over. All the commits do, but the label does not. So we've pushed the Jupyter branch, but we have not pushed the Planet branch. That's why it doesn't show up on the online server. So now let's push another branch, but remember, before you push the branch, you first have to be on that branch. So git checkout Saturn puts me on that branch, and git push origin Saturn pushes it to the server. So let's do the Venus branch also. Git checkout Venus puts us on that branch, and git push origin Venus pushes that branch up to the online repository. Notice again that the Planet branch did not go across to the origin server, even though it's part of the history of all three of the branches we did push. You might ask yourself, what would happen if I had been on the Planet branch and I tried to push the Jupyter branch? Would it go across? Would the label go across? And what would happen if I was on the Venus branch and I tried to push the Jupyter branch? Would that work? I would recommend that you go to this website and start experimenting. Really figure out what you have to do in order to get a branch to go across correctly. Next, we're going to go through the process of signing up for GitHub so that you can see what this looks like when you do it in practice. To begin with, you can Google GitHub and then hit that link. Once there, you can either sign in or sign up for an account. And once you're logged in, you should see something that looks like this. The first thing you'll want to do is create a repository for your project. You can do that either by clicking this green button, or the little plus in the upper left also gives you a way to create a new repository. That should take you to a screen that looks like this, where you can begin to fill in information for your repository. So here I've put in the name of my project, Lab 1. Next, I add a description of what it is. And next, I'll select a private repository. You may not have this option. The free accounts on GitHub generally don't. However, if you're a student or an educator, you can sign up for something called GitHub Education and get the Student Developer Pack, which will allow you to have private repositories if you wish. However, that's not the standard for the free accounts. Next, I'm going to click the green button to create a repository. However, note that I'm skipping over the option to have a README file created. The reason for this is because I've created my repository on my local machine. If I also create a file for it here on GitHub, then when I try to combine the two, things are going to get confused. So it'll make things easier for me later if I just don't make a README file here. So I click the green button. Here it explains how you're going to add the remote, that is to say the online repository, to your local Git repository in your project. But I'm going to go through all of this with you, so for now all you need to do is to copy this web address. But before I show you that, let me first show you how you add a collaborator to your project on GitHub. You first click on the Settings tab at the top, and then on Collaborators here in the sidebar. And that opens up an area where you can then type in somebody's email address and add them to the project if they already have a GitHub account. If not, ask them to get one. So let's see what that looks like on the command line. For the sake of clarity, I've gone through all the steps for creating a Git repository locally. So on this first line, you can see that I've navigated into the Lab 1 directory. Then I type git init to create the repository from scratch. Then I check that the repository has been configured correctly with the name and email address. And then I type git add helloworld.c to add that file to my staging area. And then I commit it to the repository with git commit and a message. Now I want to add a remote to this repository. That is, I want to tell it about the GitHub repository that I've got online. However, first let's check what sort of branches we have here locally. So I type git branch and it tells me that I only have the master branch. So let's create a new branch. I type git branch new function, hit enter, and git checkout new function to get onto that branch. And now let's treat this like a development area, and we're going to add a function to our helloworld.c file. So we go into the helloworld.c file, and I've added a prototype for a new function up here at the top called doNothing. And I've also added the function itself down here at the bottom. And I save my changes. Now note that I've only got one copy of my helloworld.c file, and I'm overwriting it. Normally that would mean that I could not revert these changes without doing it manually. However, as I'll show you later, with Git you can always revert back to a previous commit of the code. We go back to the command line and we type git branch to check that we're still on the new function branch, and we are. And we type git add hello-world.c to add this to the staging area for the new function branch. Hit enter, and now we'll commit it. So git commit -m and then a short message commits it to the repository for the new function branch. So now is a good time for us to add the remote so that we can push our two branches, master and new function, up to the online repository on GitHub. So remember that I told you to copy this web address. Now is when we need it. The command to add the repository is git remote add origin and then that web address, where, I will remind you, origin is just the conventional name that's given to the remote. You could name it anything. We hit enter, and then to check it, we type git remote, and the program tells us that the remote is called origin. We can also type git remote -v, and it'll tell us the exact web addresses. So now let's push our two branches up to the remote repository. First we type git checkout master to get onto the master branch. Then we type git push origin master. In other words, push to the origin remote, the local branch called master. If you're not actually logged into GitHub, it will prompt you to do so at this point. Once it has done so, it'll give you quite a bit of information, so I'm just going to scroll down a little bit. And next I'm going to check out the new function branch and push that to origin also. Remember, you have to be on that branch before you push that branch. So I type git checkout new function, hit enter, and now git push origin new function. So now that that's done, we're going to go to GitHub and think about what would happen next if you're working as part of a team. Because you could merge your new function code into the master branch and push that up to origin right now. But if you did so, it would be a little disrespectful to your team members because they should have a chance to look at the new code, and then you should decide as a team whether it's ready to be incorporated into the master branch yet. So what would normally happen after you push your new function code up to the online repository is that you then create what's called a pull request. In other words, you would request that your teammates pull your code down onto their own computers, have a look at it, and then make comments. So to create a pull request, you would first go to the correct repository on GitHub, and then you click on the pull request tab at the top. So the first thing you would do is tell the system what two pieces of code are supposed to be compared to each other. In our case, it's going to be the new function code compared to the master branch code. So this is me selecting the new function code as the comparison. And now I can click the Create Pull Request button, but before I do that, first let me scroll down a little to show you something. Down here, the website actually shows you the differences between the old code and the new code, so your teammates can check those differences online. So scrolling back up, we'll now click that Create Pull Request button. That leads to an area where you can add a message for your teammates to read about what changes you've made. Then you click the green button. That posts it, and if I scroll down a little bit, that brings you to an area where your teammates can now make comments, so you can discuss the code online. So I'll pretend to be one of the teammates now. I'll add a comment and then post it using the green button. And now you see it posted. And I'll pretend to be a different teammate now. Add another comment, post it again. So once everybody in the group is happy with the new function code, then you can have the person in your group who is acting as the administrator merge the new function code into the master branch. And then everybody in the group will be able to pull the new master code down to their own local computer. To merge the new function code into the master code, the administrator can click this button, and then they confirm the merge. Once that's done, you'll notice that there's a button here that allows the administrator to revert the changes. I'll explain more about how to revert changes later in this video. There's also a button that allows them to delete the branch, the new function branch, which is probably a good idea given that the new function branch was just a development area that somebody was using to create their new function. So clicking that gets rid of the new function branch on the online repository. So now let's go back to the command line and pull those changes down to our local computer. First we type git log to see what commits we have locally. And it shows us that we've got 3 commits, but none of them is the merge commit that happened online. We have to pull that change still. So first we check which branch we're on. So we type git branch, and it shows that we're still on the new function branch. So we better change because it's actually the master branch that we want to pull. And remember, you have to be on that branch before you push or pull that branch. So git checkout master puts us back on the master branch. And I'll scroll up a little bit here. And now I'm going to pull the changes to the master branch down from the remote origin to my local machine. And the command to do that is git pull origin master. So pull from origin the master branch. So that's done. So I'm going to remind you that on my local machine, I still have that new function branch. It still exists, but that branch has now been deleted off of the online repository. So what happens if I try to pull that branch down to my local machine now? So I'll scroll up a little bit here, and I'll start by getting onto the new function branch by typing git checkout new function, and then I'll type git pull origin new function. But that just gives me an error message because that branch doesn't exist on the remote server anymore, so I can't pull it down to my machine anymore. So let's see what we did get on the branch that we were able to pull, the master branch. We start by switching onto that branch with git checkout master, and then we type git log to see what commit history we have in our local repository now. And we see that we now have 4 commits instead of 3, and that the last one is the merge commit that happened on GitHub. So we successfully pulled that commit history down to our local machine. Next, I'm going to talk about how you roll back changes in your code using Git. And I'm going to start off by using this visualization tool again. So let's say, for the sake of argument, that one of your team members has created some terrible piece of code, for example, a function that does nothing, and your administrator has already foolishly merged this into the master branch. How do you undo this mistake? I'll warn you that because this is a merge commit, it's going to be a little more complicated than if it was just a single, simple commit. So there's 3 ways you might attempt to undo this mistake. One of them is a bad idea. 2 of them are good ideas, but it depends on what situation you're in. So let me show you what the bad idea is first. This is something you should not do. You can go back to any commit in your commit history using the checkout command. So let me show you how you could go back 1 commit. If I type git checkout master -1, it takes me back 1 commit, so the head has moved back 1 step. If I make a new commit, it gives me what looks like a new branch, but notice that there's no label on that branch. If I now switch to a different branch, for example with git checkout feature, then that branch essentially gets orphaned and I can never get back to it. This is why I say it's a bad idea to try to undo mistakes by going back a commit and then attempting to branch off of that. The label on the master branch didn't move properly when we went back a step. So here's the first of the 2 good ways to roll back a commit. So first let me go back where we started, and the command that I'm going to use to undo this merge is reset. So when I type git reset --hard master -1, that discards the last commit, that merge commit, and moves me back 1 step, except this time the label, master, came with us. But I'm not done yet. I also want to discard the last commit on the feature branch, where the terrible code was. So I'm going to switch to the feature branch now. So git checkout feature does that, and git reset --hard feature -1 discards the last commit on the feature branch. So now I can go back to the master branch and merge the corrected feature branch into it. Git checkout master moves me onto the master branch. Git merge feature then merges the feature branch into the master branch. So now you can continue making commits on the master branch and it's like that bad code never happened. Now, as I said, reset is one of 2 good ways to undo a commit that you're not happy with. So I'm going to show you the other one now and then explain why one is better than the other depending on the situation. So here I've reset the visualization tool again. And the command we're going to use to undo the commit history in this case is revert. Except that technically what revert does is it does not undo the commit history. What revert does is it creates a new commit that undoes whatever was done in the last commit. In other words, it's going to create a new commit over here that should be identical to this commit. So let's try to do that now. So I type git revert master, but I immediately get an error message that says it cannot revert a merged commit without specifying a main line with the -m command. So what does all of that mean? Well, because this last commit was a merge commit, it has 2 parents. So to use the revert command, we have to tell the program which parent it's trying to revert to. Now you'll remember that in order to merge these 2 branches, we had to be on the master branch and then merge the feature branch into it. So the master branch is the primary branch, the feature branch is the secondary branch. When we use the revert command on a merge, we have to tell the program you're trying to revert back to the parent that was on the primary branch. We do that with the -m command. So I've typed git revert -m1 master. And the program has created a new commit over here that is identical to this commit, not this one. And that's because I typed -m1 rather than -m2. In other words, the primary branch, not the secondary branch. Now, as before, we're not done yet. We still want to get rid of this bad commit. So we'll start by changing onto the feature branch with git checkout feature, and then we'll undo that commit with git revert feature. And we don't need anything extra this time because it was not a merge commit. There's only one parent. As before, the way in which revert undoes the changes is it creates a new commit that should be identical to this commit over here. So now we can switch back to the master branch with git checkout master and merge the two commits with git merge feature. And again, we can now make new commits on the master branch, and it's like that bad code never happened. So the only question now is, when is it better to use reset and when is it better to use revert? When you use reset, you're basically discarding a commit, so it's like you deleted it. When you're just working on your own private repository, that's fine. Go ahead and use reset. When you're working with other people and a shared repository, however, it's considered much safer to use revert. This is because revert makes a new commit rather than deleting the old one. The danger with reset is that if one of your team members has pulled the code to their local computer and are working on it, and you then discard the commit that they're working on from the online repository, then they won't be able to upload their code later. If you use revert instead of reset, then the commit still exists and your team member can still upload their work. You'll still have to figure out how to implement their changes, given that they were working on code that is now obsolete, but at least it's possible. So revert is non-destructive, and that's why it's better for working with a group of people and a shared repository. So now I want to show explicitly what this looks like on your own local repository when you use one of these techniques. So here I'm looking at my local copy of helloworld.c, and as you can see, it's got this do nothing function in it. So I'm going to go to the command line and show you that if I use reset to go back to an earlier commit, that this function disappears. So to begin with, I need to be on the master branch, so I type git checkout master. And then I'm going to use reset to discard the last commit only. So I type git reset --hard master ~1. And now I can go back into my helloworld.c file and see if it changed anything. And as you can see, it has. That do nothing function is simply gone. So when you use git to roll back a feature, it literally does reach into your files and change them back. That concludes this video. The next one in the series will be a very short video about how to use Git through the developer environment MPLAB X. I'll also mention that although these videos are enough to get you started using Git, there's a lot of commands that I haven't covered, like how to amend a commit that you've already made or how to cherry pick the changes that you make. So you may want to explore more on your own about what you can do with Git, because there is a lot more than I've covered. Thank you for watching.